This is Geometry, Semester 2. It's a unit called Congruence Review, so it's a review unit, and it's unit number 12. It's lesson number 1 of that unit, called SSS and SAS practice, as we'll find out here really quickly. SSS stands for side, 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 and SAS stands for side, angle, side, and it's dealing with congruence, which in geometry means equal. This is from creatormath.com under the Geometry tab. You might have to type into Google creatormath.weebly.com to find the site. Sometimes it can be a little bit tough to find. Copy the following problems into your composition book on the correct pages according to the table of contents with notes for those pages from creatormath.com. So to model this for you a little bit, this is creatormath.weebly.com, and here's what the site looks like. Here's the home page. Just to orient you to if you're in the right place, you're going to click on Geometry because that's where all the notes are and the videos and etc. Though we're going to pass by vocabulary, which is very important for your vocabulary assignments. All of your help there is provided. We're going to go to Semester 2, Table of Contents. This all should have been written long ago on pages 2 through 6 of your composition book. If you don't have it yet, you're writing this entire table of contents on pages 2 through 6. We're going to find the correct unit. I'm passing by other units here. And we're all the way down at 11. So we're pretty far down. Let's see, under Rigid Motions Review. Here, Congruence Review. And there's 2 lessons. That's because it's a review unit. This one is SSS and SAS Congruence Postulate page. Here's where it goes in your composition book. Please look at the current table of contents, not this video, because by the time you watch this video, it's probably been changed. The notes will be attached to this link here. The problems we're looking at now are at this link, and the video that we make right now will be on this link. All right, that's how you find everything and how you get your composition book up to date and how you know the background material for what's being covered in these problem sets. So, are these triangles congruent? If so, why? So, congruent in geometry means that the two, whatever we're talking about, and it's usually shapes, are exactly the same. So, the interesting thing about, just a tiny bit of background, we're not going to redo the notes here, but if you have 2 triangles, right, and you say, hey, these are exactly the same, you're talking about multiple aspects of equality, right? So we have an equals. Why don't we just use equals in geometry? My 2 cents worth is congruent means multiple aspects of equality. So this side here, which is the corresponding side to this side, they are in equal length. This angle here, which is corresponding to this angle here, they are in equal measure. This side here, which corresponds with this side here, correspond means it's the same location but on a different shape. These 2 sides correspond to each other. They are the exact same length. This angle here corresponds to this angle here. They are the exact same measure. This side here corresponds with this side here. They are the exact same length. So we're not just saying 3 equals 3. That's a single aspect of equality. We're saying that this shape equals this shape, which is multiple aspects of equality. It's, in this case, side lengths and angles, right? And I didn't do the third angle, 1, 2, 3. This one is a corresponding angle to this one, and the 3 tick marks tell us that these 2 angles are exactly the same. So that's what congruent means in geometry. So we often have, us teachers, us geometry teachers are saying, don't use equals anymore in geometry, please use the word congruent. And especially when you're talking about 2 shapes that you're saying are equal or the same shape. They are equal in multiple aspects. The angles are all equal and the side lengths are all equal. It's multiple aspects of equality. So that's my best way of explaining why we use the word congruent instead of just using equal in geometry. All right, so let's look at this setup here. This is a classic setup of 2 line segments crossing each other in an intersection. The great thing about this intersection is this angle here and this angle here are vertical angles. Vertical angles are not necessarily up and down from each other. They are across from each other, and so vertical angles is a lousy name. They should be called across from each other angles. These happen to be horizontal, and that always confuses students. Nope. Vertical does not mean up and down in this case, it means across from each other. And these angles are equal to each other. So this angle here is equal to this one of these two triangles. Now it is true too, because these are vertical here, this angle is equal to this one, but we don't need that for this case. We're looking at these two triangles, and we're trying to establish, are they congruent? Well, there are different postulates we can use, and in this case we have a side, 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 and a side, angle, side. Come on, focus. There we go. What we have here is, see this side here, 6? Then we have an equal angle to over here, and then we have a side length 4. Over here we have a side length 6, and an equal angle to this one, and then a side length 4. So we have an equal side, an equal angle, and an equal side, and that's equal to this triangle, equal side, equal angle, and equal side. Therefore, we are allowed to say that these two triangles are congruent. That information that's provided is enough for us to determine that these two triangles are congruent to each other or exactly equal. Now, you could, if you could rotate this one around, and it should line up exactly on top of this one, then you can go, oh, they're congruent. But we're going to use the side, angle, side, here it is, side, angle, side, congruency postulate. So yes, they are congruent. Why? Because of the side, angle, side, congruency postulate. Assuming the following triangles are congruent, which is the proper notation? So this is interesting. They're telling us the two are congruent, and now they're asking you how to write this notation. And this is another problem in geometry for students. They have to learn a lot about notation, and it can be quite confusing. So here we start with a triangle ABC, and all of these do. So the question is, which one lines up? So let's map this out. Here's A, here's B, here's C. And notice there's a triangle symbol, so they say triangle ABC. That's how you name that triangle. And we're naming the vertices, or the angles, the three of the triangle. That's why there's three. And we're going ABC, we're going in this order. Well, what we want to do is now use the congruency symbol, which is an equal sign with a squiggly over it. And I always say, look, it's more than equals, it's congruence, right? It's just sort of a phrase that means congruency is multiple aspects of equality to me. So now I want to go in the same order. Since they went A, B, C, I'm going to end up on C with this one. So whichever way I go, C is going to be my last letter, because we went A, B, C. The question is, which is the corresponding vertex to this one? Well, it happens to be that since this is side 4 and this is side 4, this is going to be the corresponding angle to A. Corresponding means, corresponding, we've used it, corresponding, means the same location but on a different shape. Okay, so the corresponding angle of A is going to be E. How do we know? Because it's on the segment 4, the segment 4 over here. So we're going to go in the same order. E, D, C. E, D, C. So now we just have to find the right one. We're going to put, oh, thank you very much. Let's put that in there. The triangle symbol to say triangle ABC is congruent to triangle EDC. And this is it right here. My answers are all going to show up in the A position. Your A being A, B, C, D, E. Yours are going to show up in a random position on your assignment. Keep that in mind. All right, let's see if we can go slightly faster here. Assuming the following triangles are congruent, which side corresponds to AB? So if this is AB here, which side corresponds to it? Testing us on it's the same location but on a different shape. The same location's over here. And since we went A to B, I'd like to go E to D. Why? Because the E is next to the 4, the A is next to the 4 segment. So I know these are corresponding locations. I'd like to say ED. Are these triangles congruent? If so, why? So let's look again. We love to have these segments that intersect because they create vertical angles. We know that these two angles of these two triangles are equal. So now we can look at dimensions. Here's a 6 segment, an equal angle, and a 4. Here's a 6 segment, an equal angle, and a 4. So I know that this is going to be side, angle, side. So yes, side, angle, side congruency postulate says that these two triangles are congruent. Assuming the following are congruent, what is the proper notation? So let's do it again. They gave us triangle ABC, so let's start with triangle ABC, and let's map that out. A, B, C. We're now going to go in the same direction, but on the corresponding parts. So this A is attached to the 6, this E is attached to the 6. So I'm going to go E, B, D, and in the same order, but on the other triangle. So is congruent to, let's get my congruency symbol in there, triangle, E, B, D. So I went A, B, C, E, B, D, and how did I know? I was looking at the dimension of these segments to tell me which angle corresponds to A in this other triangle, and it's got to be E because it's also on the 6th segment. So EBD, EBD, first one here. Assuming the following triangles are congruent, which side corresponds to AB? So AB is here, and we already worked with this one a while, so I know that this is going to be EB. And I'm going to go in the same direction. If this one went A to B, I'm not going to go B to E. That would be this direction and that direction. I went this direction, so I'm going to go this direction, EB. I appreciate that. This is seemingly simple things that often trip up students. Are these triangles congruent? If so, why? So let's look at this one. This one we have two triangles that share a side. It's a leg because it's attached to a 90. If this is 90, this has to be 90, right? Has to be, because this is a line and this is a line, and if this is 90, these two together would be supplementary. They add to 180. 180 minus this 90 would be 90 here. So I know that they share this angle. This is telling me, this tick mark says that this length is the same as this length. So I have a side angle, and look at this. This side has to be the same because they share that side. So we would do I guess a double tick mark maybe to show that both of these are both triangles. So it looks like I got a side angle side. Yes, side angle side congruency postulate. And I think we're going to learn another one here. Let's keep going. And again, check the notes to make sure you've got this in your comp book. This is just the problem set, so we're not explaining everything. Are these triangles congruent? There's not enough information to tell. So notice it's the same setup we already had, but we do not have the tick marks showing these sides equal. You're not allowed just, if I go, hey, this looks the same, nope, no. You're not allowed to do that in geometry. You're not allowed to use the visual because this could be not drawn to scale, okay? Not drawn to scale would be, in other words, this side could be, let's just, play it out. Let's say this side were slightly longer, but we didn't draw it right? These are not congruent. This one's clearly different than that one, and now I am using the, just looking at it. But this side could be a different length than that one. Unless they tell us they're the same length sides, we can't go on this. So this is not enough information to tell. That's one of the hardest questions in geometry. Do I not have enough information to tell? Given the following parallelogram, are these triangles congruent? If so, why? So the interesting thing about a parallelogram, which you got to know from prior lessons, is that opposite angles are equal to each other. So these two angles are equal. We know that these sides are equal here. We know that in a parallelogram, this side is equal length to this side. We could draw a tick mark. And we know that this side is equal length to this side. We could draw two tick marks. So what you've got here is a lot of information. I mean, we see that all three sides are the same. Look, this side, 1, 2, 3 sides are the same. This side's the same to both because it's shared. This side's the same. So I would go with the simplest side, 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 but I also could use side, angle, side on this too. You guys, I could use multiple ones. So I would use this one, the side, side, side. And I would be tempted by this other one. Do they tell me multiple answers? I think this one might be an option too, but I'm definitely going to choose this one, right, for now. I think that's where they were headed with this example. Are these triangles congruent? So they're telling us 1, 2, these two sides are equal in length, these two sides are equal in length, and this is shared, so this is equal. So are these two triangles congruent? Yes, side, side, side. Again, it becomes a parallelogram, which says that opposite angles are equal, so I would again be tempted by this. There might be two answers to this one. Are these triangles congruent? If so, why? So, do they look the same? No. They look different, right? But, and this was done on purpose with this one, I believe. But look, here's a side. it's the same length as this. So even though they look different, they are literally telling us these are equal length. So don't look at the shape. Look at what they're telling us. That side's equal, this one's equal here, and this one's equal here. So this would be side, side, side. These are congruent according to the tick marks they're telling us. It's just not drawn to scale. Not drawn to scale. Okay? It wasn't drawn accurately, but that doesn't change the fact that they're telling us straight out. This side is equal to this one. This side is equal in length to this one. This side is equal in length to this one. Yes, these are congruent by side, side, side congruency postulate. Are these triangles congruent? If so, why? So, this one's a little bit troubling. Let's look a little bit closely at this. We have an angle the same here. This angle is the same as this one. Then let's next go look at this angle. This angle is the same as this one. So we have an angle equal and then an angle equal. But this one says this side is equal to this side. Look at, they're in different places. This one is attached to the double tick mark. That would be this one. This one is attached to the single tick mark. And they're saying these are equal. So I would say in this one we do not have enough information to tell. We don't know. And just to play devil's advocate, let's say you stretch this side out longer, right? Can't these two angles be equal? Sure they can, right? Let's draw them different shapes. And can't this side here be the same as this one? Yeah, I'm going to go with not enough information to tell, all right? Because I don't like it. Now, if they had said that this tick mark was right here, not here, but here, then yes, they would be. Because that would be angle, angle, side. I would go on that one, which is one of the congruency postulates, angle, angle, side. All right, but we're going to stick with our answer for now. I think that's where they were headed with that example. Are these triangles congruent? If so, why? Are these congruent? So we have side lengths, 1, and that's the smallest. Let's match it up with 4. Are 1 and 4 equal? No. 2, that matches up with 5, and 3. So, no, I mean, they're not. No. I mean, there's nothing there to say. They're just different measures, right? And I would start to go to similarity. Similarity means proportional, but that's not a problem here, so we're going to ignore that for now. And if you doubled 1, it would be 2. If you doubled 2, it would be 4. And if you doubled 3, it would be 6. So these are not even similar. Not even similar. And that's not their question anyway. A little bit off topic, but we've had similarity already by this point in the course. So I'm hoping you remember that means proportional. So are these triangles congruent? This side's equal to this side's equal to this side. Well, Oh, but look at the length over here, 6 and 7. That would make this angle one thing and this angle another. No, these are not. These are not. We want to use side angle side congruency postulate, but we cannot because these two angles are different. They are not equal. Right? So no. Are these triangles congruent? If so, why? So this side is equal to this side, that's good. This side's equal to this side, good. But look at the angle. 32 degrees here, 32 degrees, 33 degrees here. Same situation as prior. They're just using a different way to tell us these angles are different. Nope. This is not side angle side. This would have to be the exact same measure of that one to be side angle side congruency postulate, and it's not. Are these triangles congruent? If so, why? So, okay, so now they're lining it up for us. Side is equal to side, side is equal to side. Those are corresponding parts, and they're equal. And this is 44 and 44. It's an equal angle, and it's in between the two given sides that are corresponding and equal. So yes, we can say these are congruent because of side, angle, side. Are these triangles congruent? If so, why? Oh, so side, angle, side. Side, angle, side. Yes, side, angle, side. At this point, easy, because we've done like 4 of those, right? All right, make sure you're matching up the title. This is a review unit. This is Geometry, Semester 2. It's Congruency Review. It's Unit 12. It's the first lesson inside of that called SSS and SAS, which stands for Side, 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 and Side Angle Side Practice. It's on creatormath.com under the Geometry tab. Hope this helps.